In this video, we'll go through a common type of equation, quadratics. So a quadratic is an equation in this form: ax squared plus bx plus c is equal to 0. X is our variable, while a, b, and c are numbers. Note that a cannot be equal to 0. One way to work with quadratics is to graph them visually. To do that, we can graph it as a function of x. So if you're not familiar with functions, we'll be talking about that in our next video. And the shape we would get would be these parabolas, either concave down or convex up, depending on whether a is negative or positive. To find the solution to our earlier equation, we would then identify the roots, or where the graph intercepts the x-axis. So depending on the shape, depending on where it is, we can see that there are either two solutions, one solution, or no solution. When approaching a quadratic equation, there are various tactics we can use to solve it. So we'll go through them one by one. And then, though, before we go into it, let's do a quick review on how to expand brackets. So to expand a bracket, we would multiply each term in the first bracket with each term in the second. So firstly, let's start with this x over here. I'm going to multiply it by x and multiply it by 6x, which would give me x squared plus minus 6x. And then let's go ahead and work with the 5. So it'll be 5 times x and 5 times 6. So 5 times x is simply 5x. 5 times minus 6 actually would give us minus 30. Okay, and then all I have to do is collect the like terms. So then this would then simplify to x squared minus x minus 30. Okay, so what is factorization? Factorization is just the opposite of expanding, where we take our quadratic equation and write it in this form instead. And to do that, we just follow these steps. So the easiest way to understand this is to do an example. So let's say we're trying to factorize this quadratic equation, 2x squared minus 2x minus 4. So first thing is, let's factor out a. So in our case, a is 2. And to factorize it, I'm going to go ahead and move 2 outside. Oh, that should be minus 2. Okay, so now that we've factored that out, let's not forget the other side, which is equal to 0. Next, let's go ahead and find the factor pairs. So the factor pairs is we're going to look at our constant number here and list out all the possible factors for minus 2. So the possible factors here is either 2 and minus 1 or minus 2 and 1. If we're going to check for the sums of these, we would get 2 minus 1 is 1, minus 2 plus 1 is minus 1. With this sum, I'm going to then compare it to the coefficient of x. The coefficient of x here is just minus 1, which means the factor pair we'll need for this factorization is minus 2 and 1. With these factor pairs, we're going to rewrite the equation over here. And so I'm going to take x minus 2, which is our first factor, and x plus 1, which is our second factor. And if you are not confident that this is correct, you can go ahead and expand it out and confirm that you return back to the original equation. Now, since these are all multiplied together and it's equal to 0, we know at least one of these must be 0. And so now let's go ahead and figure out what are the cases where one of these would be equal to 0. And we find that the possible solutions are x is equal to minus 2, or x is equal to 2, and x is equal to minus 1. And we have gone ahead and solved this quadratic equation. The next method is completing the square. So this requires rearranging the equation into this form over here. Okay. And let's go ahead again, complete these steps by following an example. Okay. So firstly, we need to divide by a. In our case, a is just 1, so we don't have to actually worry about this step, and move on to 2. Move the constant to the right. So I'm going to go ahead, take my equation, squared plus 6x is equal to minus 6. Next, we're going to complete the square. And so to complete the square, we're going to have to calculate this value over here. So I need to take the coefficient of x divided by 2 and square that value, which will give me 9. So I'm going to add this 9 to both sides. So I'll do x squared plus 6x plus 9 equal to minus 6 plus 9. Okay. Now I can see by the way that we chose this, we can rewrite the left-hand side as x plus 3 squared. Okay. And I'm just going to simplify the right-hand side to be 3. Okay. Now I can go ahead and solve for x by square rooting both sides and then solving the rest. So firstly, I would get that x plus 3 is equal to plus or minus the square root of 3, which will leave x to be plus or minus the square root of 3 minus 3. And we have solved our quadratic equation here. The last method is the quadratic formula. And so we would basically just plug in the values of a, b, and c into this formula. So given this equation, let's go ahead try it. So we would get that x is equal to minus b, which is minus 7, plus or minus the square root of b squared minus 4ac. All of that is inside that square bracket. And I'm going to divide everything by 2a, which is just 2 times 1. So let's go ahead and write this out a bit more simply. Root of 49 minus 44 all over 2. And from there, I can see that the quadratic equation would just be solved by this value over here. Half of minus 7 plus or minus the square root of 5. One thing to also note from the quadratic formula is something called the discriminant, which is the difference that is inside the square root. This discriminant can already tell us how many solutions a quadratic equation has. If the discriminant is greater than 0, there are 2 solutions. If the discriminant is equal to 0, there is 1 solution. And if the discriminant is less than 0, we have no solution, since we can't square root a negative number. Quadratics can also help us with equations with absolute signs, since the square of a value is always positive, right? So using this rule, let's take a look at an example. Let's say x plus 3 absolute is equal to 4. Let's go ahead and first square both sides. And when we do this, we can get rid of the absolute sign. So we can do x squared plus 6x plus 9 is equal to 16. Let's go ahead and bring everything to one side. And then once I look at this, I can see I can actually just factor this with 7 and minus 1. And so the solutions I get would either be x is minus 7 or x is 1. Another place where we may find quadratics handy are rational equations, which are equations that contain fractions. So this would be an example of one over here. And so let's go ahead and dive into it. So one thing I'm going to want to do is simplify this denominator over here. And one thing you might also notice is we can easily factor this, right? We can factor this to be x minus 3, x minus 2. And so this we can also identify as the lowest common factor. So let's go ahead and multiply all our terms by our lowest common factor. So when we do this, we would get 4x minus 2 plus x minus 3 is equal to 4. So we can expand and collect the like terms. So we just have 1x squared. And then in terms of x, we have 4x minus 3x, so we would just get x. And then we have minus 8 over here. And let's go ahead and also bring this 4 to the other side too. So then we have it equal to 0. From there, I'm just going to gather this 8 and 4. And again, I can see that this we can factor fairly easily and solve that x is either 3 or x is minus 4. Okay. And then lastly, we have something called radical equations, which uses a root instead of a power. And so, for instance, to solve something like this, first I would go ahead and get the root on one side and isolate that. And then let's go ahead, square both sides. And then with this is fairly easy to then solve for x. Okay. And that is our section on quadratics equations.